Hi, I'm Deriv'era, and over here I have Subor, the Russian educational computer from early 90s that simply beats all the modern machines by the inability to access social media. Such a blessing nowadays. Straight away you notice quality. Awful quality. Insane by the amount of mistakes in the documentation and even in the title of its main cartridge. The title should say обучающий cartridge or educational cartridge. Both Russian words over here I spelled wrongly. Обучающий cartridge. In the documentation, aside of sentences without any particular meaning, there is also some occasional Chinese language. I have two Subors and I feel extremely rich because of how insane is the price for them is currently on eBay. Only DDR5 beats this level of inflation. From two Subors I'm going to build one fully functional cause each of them has defects. First one is missing some keycaps and pins are broken, so I'm going to transplant these pins from the second machine. Cross-connector keycaps from Subor is compatible with Cherry MX. Sadly you can't install Cherry MX into this thing without full rework of the machine, but considering the quality of this keyboard, I'm really trying to figure out this problem. Instead of default cross connectors, my first one has quad connectors, and these ones are awful cause they break very easily. They are not broken by accident or Russian approach to handling things, they are literally so fragile even I broke one, and I tried to be extremely gentle. Post-Soviet engineering consists of everything being soldered and hot glued together. I guess they didn't have cable ports of any sorts or ports were too expensive. The only exclusion from this monumental everything soldered design is how keyboard mat is connected to the board on the right. They press it down with this piece of metal to make the connection. It doesn't look very sturdy, but it survived for more than 30 years. Survivorship bias, I bet. In the manual, this keyboard is called high-tech, and I need to admit that probably for post-Soviet world it was high-tech. It still has better construction than Spectrum's rubber keyboard from 1982, at least I think so, I never held this Spectrum in my hands. It is as well weaker than Spectrum in all possible ways aside from Famicom graphical engine. In the process I cleaned the cases and buttons out of dead Russian insects, sunflower seed shells and some objects of unknown origins. First machine also has a strange cable coming out of the case. I initially thought it might be an antenna, but it appeared to be connected to DC input. I assume AC adapter broke and the owner decided to fix it this way. The second machine might be overall dead to restore. The cartridge port over here is broken on the inside, and after some search I found out that it looks like it is not using some kind of original 60-pin port. I will still order 60-pin Famicom port and try to squeeze it in, but screw points seem to be different. If you know which kind of port it is exactly, please let me know in comments. I've got both machines from Russia extremely cheaply. I know a person who traveled through Russia from Serbia to Emirates due to heavy machinery support job he did, and he stayed in Russia for a few days. Pretty brave person, I would say, considering buzzing things in the air and explosion across the country. Police stopping you all the time, but people want to eat, you know, so they do these dangerous job-related travels. Sometimes you need to take a risk to have food for the next day, so they fired him anyway, but at least I've got my Subors. Subor was a thing in the whole Eastern Europe bloc and ex-USSR countries, not only on the territory of modern Russia. So you can find clones of Subor and original Subors on eBay nowadays, mostly from Ukraine. Despite the production of these machines often being referred to as Russian-Chinese collaboration out of Russian sources, in reality it has the least Russian doing possible and mostly made in China with original software from Japan. Technically speaking, it's not a Russian machine at all, it's a Famiclone that just combines some original add-ons like a keyboard into one case. Russians didn't invent anything about it aside of Russian language, and even that they did poorly, with tons of mistakes. God-awful documentation is just a translation from Chinese to Russian. Now let's take a look on the interfaces. Subor has two Famicom gamepad connectors, LPT port with a strange additional dongle. I assume it is just to make the port physically longer and stand out from the case. You could use this port with printers theoretically. I don't have an LPT printer, so I can't test it. There are no ports to connect any recording or reading devices, so you can't store and load anything. You literally need to store all your code on one of the slowest storage containers ever made, paper. Well, okay, maybe there are even slower ones, like stones, I don't know. Just use a pen to write your code and your fingers to read it back. It has mono audio and video AV output and an RF output to use antenna port on an ancient TVs without AV. After receiving Subor, I also resoldered AC adapter. I am still using the original one because why the hell not? They're unbreakable anyway. Just resolder them once in a decade and maybe change the wire once in 50 years. So in the end, my Frankenstein looks like this. It's fully functional and with all the keycaps. You may notice that some keycaps have different heights. That's normal, just legs of keycaps may differ in factory approved 2 or 3 mm. Just a disclaimer, it's a joke, I don't want to insult any Chinese workers, I don't know why they are so different. Subor planned to have more cartridges than this one with other software, but something went wrong. They never released anything else. Most likely Famicom hardware just looked outdated at this point. So Subor changed the branding and became Magister, or Magister just stole the technologies and released their own Subor under Magister brand. And later Magister, under the name of Cyber Smart, around 1998, released Sega-based keyboard. And this was a real talk because Sega Mega Drive had a really nice graphics system, 64 kilobytes of RAM and 7.6 MHz 16-bit CPU, but no one bought it. Yes, it failed completely. It's impossible to find any used Cyber Smarts in the wild. It had different names like Magister Lyceist, what a god awful name, or Keyboard or Keyboard 005. I'm not sure how to properly you should read it. That sounds even worse. I checked local Ukrainian, local Russian, online flea markets, eBay and found nothing. Very sad. Besides, on this image I don't actually see BASIC in any of the software titles in the background, so I'm not sure if they even had any BASIC for this thing. Sega supported a keyboard and it was a planned peripheral, but they never released it. In the other words, there were no official keyboard and Mega Drive BASIC. I'm using an HDMI capture card so I can provide you with a picture of poor quality, but it's better in comparison of using my phone to record the screen. Intro is honestly a banger. I literally don't remember a starting screen better than this one. It sounds like a holiday when you finally put your hands on a long-awaited gifts. Music changes after you enter the main menu, and here we can observe 7 application options. Let's check them all one by one. First is the keyboard exercises. Application highlights you a key you need to press and shows up a finger you need to use for this key. And I'm using this 10-finger method of typing, but for some keys I use different fingers. Overall, it's a good application. Also, it's in English. They 100% ripped it off somewhere and couldn't handle the translation. Second application is the entertaining typing. So we can entertain ourselves with typing. The game has 9 difficulty levels of entertainment, and all you need to do is to press a button with a letter that is falling down from the top part of the screen. Third application will educate you with some listening to Russian music. I hope I won't get a copyright strike. First one is Evenings Near Moscow. I will just straight up tell you, aside of obvious Katyusha, I never ever heard any of these songs. Zero knowledge of what these titles are. Oi, Kalina blooms! Sadly I know only Lada Kalina. It's a car. I think it's some kind of a flower also, but I'm not sure. Third one is Whom You Were, then go 3 dots. For a fan of anime like myself, it sounds like someone became a demon or died and they try to recall the memories in a 3 episodes flashback like some kind of Naruto. Also, it may have some relation to Silent Hill 2 and the search for Mary. Katyusha. It's an iconic song and people mostly hear only the first part, and I have a lot of associations to it. But the biggest one probably is Girls und Panzers. After the well-known part of the song, It actually starts to sing about dying soldiers that protect the country while Katyusha saves the love. Next song is They Are Nice During Spring and the Garden. Then 3 dot goes. Again, nothing to say, they're obviously nice if they say so. It's currently spring out there and outside is nice, that's something I can't argue with. Our toast, something about getting drunk with vodka. Imagine listening to this song during the process of vodka drinking with Subor running in the background. Probably it's an ultimate 90s Russia experience with carpet on the wall, of course. Without carpet it's not Russia. And the last one is Across the Wild Steppes of Transbaikalia. This one, at least in the title, I enjoy. But again, it doesn't ring a bell. Editing. It's a text processor. That's definitely something that wasn't made for Subor, because to navigate the menu you now need to use letters instead of numbers. It has help system that shows you what the keys actually do. It also has an ability to print your text on an LPT port printer. Last option is exit, and first, well, the editor itself. Before editing, you need to enter the file name. It doesn't make any sense because there is no storage. If you reset the system, you will lose all your so-called files. But what is more interesting, Subor introduces to you a super innovation system that was never adopted in any other software. What you type depends on the speed with which you are typing. If you slowly press ASDF, it will input ASDF, but if you type fast enough, you will get ASDG. Overall, some strange behavior occurs with any symbol combinations you enter fast. And this editor has a noticeable lag in everything you do. The fifth app is simply called Calculations. You type in values and operators, and after you type equal symbol, it shows you the result. It also has its own unique music. And those were the main entertainment apps. The last applications are GBasic and FBasic, or GameBasic and Floating Point Basic. Floating Point Basic just have some floating point calculations and floating point variables instead of normal variables, but even in the documentation it described very briefly. No one cared much about it, even the creators of Subor. GameBasic is the most interesting part about this machine, obviously. So let's jump into learning how it works. But before starting this journey, we finally need to talk about documentation in the full depth. It's made in China, Guangdong, by a company called Lico, the creator of Subor. There is no date when exactly this book was released. It existed forever, probably longer than Bible, created by God on the first day of creation. The description starts from the statement that Subor has both gaming and educational processors, whatever this means. High quality and top of the technology keyboard. I have Logitech YSU45 that entered production in 1998, and in comparison to Subor, it's heaven and hell, and SU45 is just a cheap office keyboard. I can, without any problems, use it instead of my MS Keys S. Amount of mistakes in Russian language is from 3 to 10 per page. I have a feeling that writer didn't know Russian language. No one did corrections of this writing, and they never touched this machine in practice. I think they never ever saw Subor in real life. Just let me translate you one sentence for illustrational purposes. Value of file economy CGset: CGset 1.1. Because of it, code of multiplication layer 1. Combination code of color is 3. If it doesn't make a fucking sense to you, I assure you, it doesn't make any fucking sense to me as well. File is a function that doesn't return a value. Probably it's an old basic language slang, I'm not sure. Multiplication layer is some kind of internal layer that they never explain. It works on Famicom sprite layer, but sprite's movement is controlled by BASIC itself. You just give commands about direction and endpoints. This could be a solid programming book because they actually start with schemes of programming flow. They explain different aspects of programming. But the language itself and explanations are just not even outdated, they are just straight out bad. It sounds like they assume you have a lot of knowledge, but for some reason you read about beginner stuff. Also, they introduce commands that they explain only after a few pages. That's the thing I personally hated the most. Never do this in education. It's like reading a text with new words, but new words are introduced much later. And if first part of the book is quite beginner friendly, you can learn how to make a simple for next loop, how to print text. Books explains how to use strings, input and output. At some point, this book turns into full Dark Souls, because they explain how to use Famicom hardware without explaining how this hardware actually works, and they assume you understand their weird ideas when they didn't even present them. For example, clear, poke and pick commands allow you to work with memory directly, and they just give you a random address to write data to it. Now let me translate this to you. Clear command sets the limits of the internal memory of subscription program. This sentence comes from nowhere and has completely no meaning to me. Just by the name of the command I can assume it clears the block of memory, but not by their explanation, and I'm not sure I'm actually right. Poke and pick save and read bytes by their addresses, but all numeric variables in GBasic are signed. In other words, they go from minus 32,668 to 32,767, while memory goes from 0 up to 65,535. And you can't use negative addresses from variables to use with memory. Because of this, you can only read and write half of the memory space. By the way, they don't explain it much in the book. For sure, Famicom has much less memory, but hardware, internal memory and cartridge memory are mapped to different addresses in this global space. I tried to find GBasic screen buffer by byte search in memory, but it looks like the GBasic is directly using only video memory to store what you type, plus some additional memory for commands I was able to find. But address of commands is more on the useless side. It's sad because access to video memory directly is not simple, more on this later. So I know how memory works in 8-bit CPUs, and I googled memory organization inside Famicom hardware. Without reading about it somewhere else, it's simply very hard to use these commands and find meaning in them. Just by writing to random addresses, you can ruin your code in the memory or GBasic itself and break the machine until the reset. And reset, mind you, destroys all the code you wrote. They also lie about functionality. For example, over here they say that it has rich musical and sound capabilities. It literally can only beep. Hey, it's Deriv'era from the long future, 3 months apart from the original script. In the last moments of editing of this video, I found out that actually Subor can do more. Ability to play additional sounds described in 3 lines of text in a random place of the book. GBasic is able to play notes with octaves using a string format. It's still hard to call extensive music capabilities, but it's more than a beep. Future Deriv'era out. The explanation of how the computer works overall is a fantasy description of some kind of a beast from D&D. Just let me translate it for you. Manipulator, by the task of the program, provides commands of control. Programs inputted in advance are stored in memory and set up the order of operation completion. Manipulator calls commands from the memorizing device one by one, analyzes them, sends electrical signals which determine completion of related operations in different blocks of the computer. Manipulator together with arithmetical unit are called central operational unit, which is core of the computer. Yes, they're trying to describe how CPU works. I understand it only because I know how CPU works, and before this word salad even starts to make sense, you need to read it a few times. But even if somehow you will be able to grab something from it, the problem is they don't talk about the architecture of Famicom, while this computer is based on it, and they don't even touch how it actually renders graphics using sprites, limitations and other stuff. But enough about it, I will just compile the knowledge for you by myself. Famicom has 8-bit CPU. It has several 8-bit internal registers. Think of them like small storages on which it is able to execute operations. CPU of almost any architecture is able to do operations only on the registers inside it. 8-bit means that each of such storage containers can only have value from 0 to 255, or 2 in the power of 8 options. CPU loads data from memory into registers and execute functions on them. With special commands, it is able to store the result back from the register into the RAM. Some registers are combined together to form 16-bit containers. That's how CPU is able to access 64 kilobytes of memory, or 2 in the power of 16. GBasic manipulates 16-bit signed numeric variables, meaning that single variable range is from -62,768 to 32,767. It is possible to do by combining the result of 8-bit operations together, but 8-bit CPU are unable to do a 16-bit operation in one go. That's why they're 8-bit in the end. 16-bit operations for such CPUs are slower than 8-bit operations. GBasic is using 16-bit and only 16-bit signed numbers for the sake of convenience. GBasic has two types of variables, strings and numbers. Variables with $ in the end are strings. Internal functions with the $sign in the end of its names return strings as the result as well. The simplest example will be the following. We set A to be number 10, we set B$ to be a string with value A equals, then we print it with the divider. Depending on which divider you use, there will be different padding between output variables. Manual doesn't mention it, but you can use variable names with more than one letter, but you can't use numbers in names. It's important because some basic languages, like the one on ZX Spectrum, allow you only to use one letter per variable, just for the sake of performance and memory consumption. If you put a string number before the command, it will be stored in the memory, otherwise the command will be executed right away. You can enter your string numbers in any order, all the strings will get sorted internally. Usually you have some numerical gap between commands, so you can add some code in between existing commands later. If you input a string number and enter nothing, the command will then be removed. Run runs the program from memory. CLS clears the screen and ends the execution in the current line. List shows current program in the memory ordered by the string numbers. You can use break to stop at any spot. There are some commands like edit that doesn't work for some reason. In theory, you should be able to write edit and the line number and explore specific string, but again, this book mentions functionality that doesn't exist for some reason. Same with some key combinations. Book states that Ctrl+D should reset the graphical state if something went wrong. It does nothing. GBasic supports arrays, or ability to store several numbers in one variable. To create an array, you use command dim, and in the brackets, you put the desired amount of values. GBasic supports up to 5 array dimensions, and arrays are extremely slow. We will discuss it in the future. You have all of your arithmetical operations, including division and multiplication, and even mod that returns the remainder of division. But you don't have shift command to perform fast division and to work with bits. Shifting bits is one of the basic operations. Still, for bit operations you have your usual NOT, AND, OR and XOR. Funnily enough, documentation never mentions the value of binary operations and where to use them. It just shows how to check individual buttons, not the combination of buttons on the gamepad, and that's one of the examples where I can use binary operations. Read and data are extremely strange commands to me, but I can only assume they're common for BASIC. I'm just not a BASIC professional to be familiar with them. Read receives values from data blocks and stores them in variables. Data blocks can be anywhere in the program. In other words, you can read static data into variables pretty fast and in compact way because you read values linearly, no matter where and how many values you read. If you reach the end of all data blocks, it stops and shows you an error. To rewind the reading process, you can use restore. Swap swaps the values of two variables. There is pause to stop the execution for a brief moment. The number after the pause command is more about the feeling of pause, not real amount of time, so you search for the right number based on your soul. To jump between lines of code you have go to with the number of the line. There is no labels, so you're forced to use string numbers. You have your classical if-then, but you can't make conditions to execute the whole block if condition is met, and you don't have if-else condition commands. But you can write several commands in one line using colon. This is the only way to run several commands if condition is met. Documentation states that one line of code can contain 252 symbols. It's around 9 strings of code with 28 symbols per line in GBasic. GBasic supports 4 next commands to loop through the values. Also, it can receive optional step value. 1 is default. Step can be negative to loop backwards. There is also some very specific onGoTo command that receives a variable, and depending on the number in this variable, selects the execution line from the list of goto commands. I can imagine it as useful in execution depending on the gamepad button input, for example, or a simple state machine that runs code depending on the current state of the game. In addition to goto, you have goSub that allows you to use a return command to return to the place where goSub was called. Basically, it's function calling, but sadly you can't send arguments with this call. Still, it allows you to implement pieces of code that are reusable across your program, but I used it mostly to separate pieces of code into logical blocks. Creators of this book also came up with a new day of the week, Sunday. To receive string input from a user, you can use input command. If first value is a string, this string will be used as a question prompt for the input value. Input supports a list of values if you want to prompt several values. Before this, we went only through the commands that don't return values, but in GBasic there are functions that return values, and you can use them instead of variables in conditions or in place together with variables. I was honestly surprised for some reasons that GBasic can do this. For example, ABS with number in brackets will remove the sign from the value. SGN returns -1 for negative, 0 for 0, and 1 for positive values. RND provides you with a random value up to the number in brackets, another very useful one. There are some string functions that allow you to take parts of the strings and make numbers out of strings and vice versa. GBasic actually has a lot of string functionality, but I personally am completely uninterested in doing anything with strings. I prefer visuals. $$ is another important one because it returns you a value of currently pressed key or 0 if nothing is pressed. Stick and streak are used for gamepad input. As the parameter, these functions receive the number of the gamepad, so you can implement a local multiplayer. Here it is, slightly burnt original Subor gamepad. $$ is also very important because it turns a value into a string symbol. With it, you can combine several symbols that are not presented on the keyboard into a string. As a string of letters, they might not make any sense, but as an array of numbers, they are actually used by some commands. Because these commands don't use arrays created by dim, they use arrays created as strings. Very logical, I know. You have a table of available symbols in the book. Using their numeric equivalents and $, you can print them on the screen as text. Here you can see all the available symbols. So far, cursor that determines the place where we output data was fixed and controlled by GBasic itself. Locate allows you to set the cursor into any position. Symbol field is 28 columns by 24 strings. This example program draws a triangle using stars. And finally, we have enough knowledge to talk about graphics, real graphics. CGen, the book definition states the following: set the chart of symbols that are used for the background layer and multiplication layer. It has some meaning behind it, just as always with this book, it is something hard to grasp. Famicom has 2 layers. One is a matrix of 8x8 pixel sprites. Second is your dynamic sprites that can be 8x8 or 16x16 pixels in size and have any position on the screen. Those layers use different sets of graphics, so here you choose between 2 presets. Our text on the screen is using the background layer, and we are currently using a set of graphics that consist of English letters. Because letters are 8x8 sprites, so we can use letters for dynamic sprites. Or we can use predefined graphics of characters instead of letters. CG set selects color sets from predefined sets of colors. Color changes a color value of current symbol in the background by its coordinates. Aside of just basic editor, GBasic also has a tool to create backgrounds. Using this tool is a pain by itself because any action is using the most random keys you can expect. For example, selection between figures on the bottom right is using backspace and insert. I'm not sure how to even describe my frustration over it. Also, it doesn't support gamepad for some reason at all. I wish I could at least draw using a gamepad instead of a keyboard. Exiting this editor is like exiting Vim and the Linux terminal. You need to know the exit combination of buttons. Here it is, escape and break. It has menu, but menu has no exit button. So if we go back into basic editor, we can use a command view. It literally copies what we drew in Visual Editor into our text field. So in real code, you will first call CLS to clear the screen and then view to get your background. So it's static. There is no functionality to scroll it around integrated into GBasic, at least nothing mentioned in the book. And from this moment goes some advanced level coding. Remember poke command that allows you to access memory directly. Well, you can use it to directly access hardware of Famicom instead of using GBasic as a middleware. The problem is, when you access picture processing unit or PPU of the Famicom directly, you race for the access to it with GBasic. And because of this, most of the commands glitch. It makes a lot of functions you normally have access to as Famicom programmer unusable or tricky to use. Like for example, changing sprite indexes in the background directly instead of using print command. So far, from what I tried, only a few of these features worked, and one of them is scrolling of the background. But if you use scrolling, unfortunately, you can't access GBasic text output anymore because it changes the background scrolling registers. In the end, I came up with the following algorithm. You clear the screen and call view function. It copies your background art from the top right screen to the top left. Famicom has 4 screens in the video memory. 0 scrolling screen is top left. And then you scroll infinitely the horizontal plane. This way you are able to achieve infinite looped background scroll with no visible cuts. Well, creators of this still couldn't make things right, so you can only draw background art in the narrow window. GBasic tool doesn't allow you to fill the screen entirely with your art because of the interface. I believe they could come up with something like hiding the interface or making it smaller, but they didn't. For the space-style backgrounds, it actually works alright. And after this long walk, we can finally discuss sprites. And the design of this system in GBasic has a lot of compromises. Let's first look closer at the function that defines the sprite. Def sprite A, B, C, D, E, F. By the way, translators messed up the order for some reason, and E follows C and then goes D. A is the number of the sprite. You can choose from 7. B is combination of colors. You have a choice from 4 predefined palettes. C is the size of the figure. 8x8 or 16x16. There are only a few sprites that are 8x8 in default sheet. Most are 16x16. All graphics is predefined, you can't add your own options. D is priority. I like how they have 0 explanation on what it is, but I assume it's simply the order between the sprite and background. E and F are horizontal and vertical mirroring. For some reason they call it rotation when it's definitely not rotation. The command is followed by indexes of graphics pieces. This part looks a bit odd from the first glance. They make numbers into the strings, then combine string pieces into 4 symbol string that represent 4 indexes needed for a 16x16 sprite, because 16x16 sprite consists of 4 8x8 sprites. This thing is technically not a string, but an array of 4 values presented as a string. I'll write a simple piece of code that will go through all of the available sprite graphics. During this presentation, let me read the names of them. Dr. Mario, Lisa, a fly, flying fish, penguin, fireball, cart, interplanetary station, satellite killer. Why satellite kills people? I'm not really sure. Spaceship, explosion, devil, laser, tortoise, crab. And the last one is bird. They are out of an order for some reason, and in the book they refer to the table on the last pages, and it has a list of animations for each character and some additional characters like feather, computer and operator. At the same time, they have graphics for music writing. Let's move to animations. For animations, it's important to update positions and sprite graphics in the right moments. Usually, you move your sprites around and send graphics of them in the short period of vertical synchronization. It's a period around of 1 millisecond during which cathode ray tube repositions the ray from the bottom part of the screen to the top and prepares to draw the next frame. Part of an ancient CRT technology. Changing everything in this particular moment makes animations and movement to look smooth. The first problem will be the reaction time. You need to react fast on this event. Second, you need to be able to change the graphics fast enough as well, because you have small time window. Both of these problems are a problem for such a slow CPU and basic interpreter. So with what creators of GBasic came up with? It is an ability to set up movement between points. Then GBasic simply moves sprites on its own automatically. It is even able to play animations during the movement. This system might be good to show off animations, but that's far from the best approach for a responsive game. I need to control the position of the sprite and let GBasic to handle only the animation part. And it can't do it this way. If I want to manually switch display graphics of the sprites the way I want it, the book suggests me to use several sprites to do so, from a limited amount of 7, each one with its own graphics representing an animation frame. There is no code that shows you how to use animation system with the gamepad-like controls, instead of just moving sprites between points. In other words, the only way suggested by the book, and the one I used, is to make 2 sprites for 2 frames animation and show one while the second is hidden. To place a sprite in a specific area of the screen, you use function sprite that receives number of the sprite and XY position. If you call sprite with just a number, it will toggle the visibility. It's a mystery why you can't just set the visibility state. It would be just such a useful function. And what is especially annoying, there are a lot of side effects around sprites you don't expect. For example, when you define a sprite, GBasic automatically moves it to 0 position and you need to manually move it back. And because you don't sync it with vertical synchronization I described before, it will blink between 0 position and the desired position from time to time. So you can't use define sprite to change sprites frames. So when you have 2 sprites and swap their visibility, they won't blink simply because they hold their positions. That's how I animated this bird with legs. I made it to fall out of the screen and cause a game over. Let's finally discuss the actual game I was able to make using all of this knowledge. Imagine my disappointment when I plugged a gamepad at this right moment and Subor just went dead, so I needed to reset it and write the full code again. So I have a variable A for position on the screen and B for acceleration down. I change B and add B divided by 4 to A. This adds the gravity and acceleration that builds up slowly. When B button is pressed, I set B variable to minus something so bird flies higher. To prevent the constant trigger of the script, I memorize the button input after the check. This way, if you hold the button, bird still jumps only one time. So there is a weird thing they call a space station. I decided to use it as a graphics for obstacles. So I created an area of 5 obstacles for positions, created 5 sprites and wrote a simple code to move them on the screen, and the game instantly became a slideshow. And the reason is arrays. They appear to be extremely slow to access, unusable in real time, ultimate slowdown. So I just created separate variables for each sprite. I know how it sounds terrible from a programming perspective, and without any loops I manually started to update each one of them. I didn't use any for two next loops aside of sprite initialization, because this is the fastest way to implement movement. I've got relatively okayish performance on 3 obstacles. More than 3 of them drop the performance noticeably. I wrote a simple collision algorithm and also added an explosion after player's death. I've added score, and that's how the game looks like in the end. Explanation of how it works is actually much shorter than explanation of all the tools that GBasic provides to you. While you watch me playing my game, I want to make some kind of a conclusion here on pluses and minuses of this machine and my experience overall. Let's go with pluses first, there are not many. First of all, writing using a keyboard and screen when you can prototype your game fast is very fun. It's creative systems that you can use to make simple games very fast. This is one of the reasons why I love Basic overall. And its caveats, GBasic performs okay despite all of my complaints. I really enjoyed adding functionality to my small game. This machine forces you to think and plan ahead. It would be a good educational device if you had a good documentation. Without a storage and editor, you must think your way through. You can't just take some random coding decisions, you need to focus and optimize before you implement. It should improve your discipline and planning skills. Machine itself has simple construction, it's not difficult to service it, but older versions still have those easy to break rectangular pinheads. And if think these are the only positive points, now about the negatives. Awful documentation. They can't even keep the syntax right through the book. Here dev sprite is using equation, here it is using minus. A lot of stuff is not explained. Half of this book feels being written for newbies, another half feels like a manual for professionals who worked with Famicom hardware for a long time. There is no table of errors. Errors have different two-letter error codes, but you can only guess what they mean. I had a situation where I just rewrote the full string because the old one was dropping me an error that I didn't understand. Everything looked correct, but it didn't work. I knew the same string just worked. The next problem is keyboard. You need to use this keyboard a lot, and it's just awful. You can't type features fast enough, and it's annoying. Every reset means you need to type again, and this keyboard doesn't feel old, it just feels not well enough constructed when space and enter, the most used keys, trigger well only at specific locations on the button. If you miss them, you need to apply force to press the key. So you apply force to press the buttons all the time just to make sure every button press connects. I complain only about the enter button and the space bar. Other buttons are relatively okay. Third bad point is GBasic. Things just need to be done slightly different and have slightly different implementations to have better usage scenarios to open up more possibilities from what this machine actually can do. I think creators just didn't have a plan in their mind for GBasic to be used to create actual games. I have a feeling that graphical part overall was a rudimentary afterthought. I will not switch sprite graphics immediately. I will memorize my choice and switch the graphics on the next vsync, and I will provide a separate command just to switch the graphics of the existing sprite. It's not that difficult to implement, honestly. Shouldn't be, at least. Fourth is obviously performance. Famicom runs at whopping 1.79 MHz. The TX Spectrum in comparison runs twice faster, but has less powerful CPU. For GBasic, this performance is critically low. I'm not even saying anything about 4 KB of RAM. On the other side, it's not so easy to run out of it, considering other limitations. CPU of Famicom for such tasks has too many weak points, because it doesn't allow you to load your own graphics and just reads graphical data from ROM on the cartridge. It is fun to make games on it, but it's not fun at all to enter the actual code. So I would not recommend it, especially for eBay price. You can buy too many other things for this $400, like actual Russian ZX Spectrum clone for half the price. Or my game costs just $3, available for PSP and PC. PSP released on itch.io, works on real hardware or emulator. PC version is released on Steam. This way you can support this channel and the creation of my videos, projects and other stuff. Hope you enjoyed this video. If you want more games implemented on Subor, leave a comment. With enough support I will create more games, and the next time time I will try to squeeze maximum stuff into a single game. Maybe I will find more features and tricks to discuss, who knows. There is no command that prints how much memory is in use currently in the manual, so I don't even know how much was left after the implementation of my bird game. Bye, have a nice spring.